Let us see the volcanic distribution, that is hot spots. Hot spot volcanism occurs away from the tectonic plate boundaries. Hot spots are stationary sources of hot magma that rise from deep within the Earth's mantle. When a tectonic plate slowly passes over the hot spot, it forms a series of volcanoes. As the plate continues to move, older volcanoes drift away and become inactive while new ones develop above the hot spot. This type of volcanism can occur under both oceanic as well as the continental crust, but it is more common and well developed in the Pacific Ocean due to the faster movement of Pacific plates. This movement creates clear trails of volcanic islands and the seabound across the oceanic floor. Let us see the examples of hotspot volcanic chains. First one is Hawaiian, that is Emperor Seamount chain in the Pacific Ocean, and the second one is Austral Marshall Gilbert chain, that is also in the Pacific Ocean. So, these linear island chains serve as visible evidence of plate movement over stationary mantle plumes and are important indicators in understanding plate motion and the volcanic history. Let us see the regional distribution of volcanoes. Volcanoes occur in various parts of the world, but their number, type and activity levels differ depending on regional tectonic settings. While the global distribution highlights broader tectonic patterns and the regional distribution provides insight into specific zones where volcanic activity is concentrated due to local geological processes. Several countries and regions across the continents have frequent volcanic activity because of their unique plate boundary interactions or tectonic characteristics. So, Asia and the Pacific, many regions in Asia and the Pacific Islands are highly volcanic due to complex plate interactions. Japan, the Philippines and the Indonesia are part of major island arcs formed by subduction of oceanic plates, and these areas contain curved chains of volcanic islands such as the Kuril-Kamchatka arc, Aleutian arc and Indonesian arc. And the other arc system include the South Sandwich Islands, Fiji, Solomon Islands and New Hebrides, which also lie along active subduction zones. And the next one is the Kamchatka Peninsula in Russia and New Guinea, Celebes and parts of the Indian Ocean where volcanic belt also experience frequent volcanic eruptions. These regions not only host multiple active volcanoes but also face high earthquake risk due to ongoing tectonic movement. The western coasts of both North and South America are volcanically active. Here, oceanic plates are subducting beneath continental margins leading to the formation of volcanic mountain chains. And the next one is the Andes Mountains of the South America, the Cascade Range in the northwestern United States and the Canada. And the next one is the Central American Volcanic Belt as well as the Mexican Volcanic Belt. And the next one, the Aleutian Arc, part of which lies on continental crust, and these volcanic belts are known for their large stratovolcanoes and the frequent eruptions. Let us see the Oceania. Some regions in Oceania contain both arc related as well as the ridge related volcanic zones. Example, New Zealand lies on the boundary of the Pacific and Indo-Australian plates, making it highly active. And the next is island chains such as those in the Austral Marshall Gilbert chain, that is in Pacific Ocean, which are linked to volcanic activity and also serve as evidence of long-term plate movement. The third is polar and oceanic ridges. These regions like the ridges around Antarctica, East Pacific Rise, Mid-Atlantic Ridge and Carlsberg Ridge are important volcanic zones. While mostly underwater, some segments such as in island appear above sea level, making surface volcanism visible. These ridges mark the formation of new ocean crust and the early development of geological features associated with plate divergence. India experiences very limited volcanic activity, and whatever little activity exists is almost entirely confined to the Andaman and Nicobar Island located in the Bay of Bengal. These islands lie at the complex junction between the Burmese plate and the Indian plate, making the region geologically active and vulnerable to both earthquakes as well as the volcanism. So, tectonic setting of the Andaman and Nicobar region we will see. The Andaman Trench, situated to the west of the Andaman and the Nicobar archipelago, marks the subduction zone where the Indian plate is dividing under the Burmese microplate. This process, known as subduction, is responsible for the formation of island arcs and volcanic activity in the region. To the east of the island chain lies the north-southwest Andaman Fault, a strike-slip fault running through the Andaman Sea. This fault accommodates horizontal movements between the plates, adding to the seismic complexity of the region. The Andaman Sea is undergoing a tectonic process known as a sea floor spreading, which is similar to the process occurring in the Atlantic Ocean. So, this process involves the formation of new oceanic crust along underwater ridges, causing the sea floor to gradually widen over time. Due to these tectonic interactions, the region experiences frequent shallow to intermediate depth earthquakes, which trace the path of the subducting slab beneath the islands. This earthquake activity is part of a broader seismic zone that extends into the Indo-Burma ranges on the mainland. In historical times, several high magnitude earthquakes have struck this region, triggering geological changes and contributing to the formation of a chain of volcanic islands.